Why are all the stars fixed in space? The stars are not fixed, but are constantly moving. If you factor out the daily arcing motion of the stars across the sky due to the Earth's rotation, you end up with a pattern of stars that seems to never change. The stars seem so fixed that ancient skygazers mentally connected the stars into figures, constellations, that we can still make out today. But in reality, the stars are constantly moving. They are just so far away that the naked eye cannot detect their movement. But sensitive instruments can detect their movement. Consider driving down the highway in the mountains at 60 miles per hour. The telephone poles on the side of the road seem to whiz past you, but the distant mountains seem to hardly move at all. In fact, they are both traveling at the same speed, 60 miles per hour, relative to you. The mountains just seem to move slower than the telephone poles because of a perspective effect known as parallax. In general, the more distant an object, the less it moves in your field of view for a certain, fixed actual speed. The stars, even the closest ones, are vastly farther away than the mountains, so their motion in our field of view is minuscule. But they are still moving. Most of the stars you see in the night sky with your naked eye are individual stars inside our own galaxy. It takes telescopes to see the stars outside our galaxy or even to see other galaxies. The stars in our galaxy are all orbiting in a nearly circular path around the center of the galaxy. They do this because the immense combined mass of the galaxy, most of it near the center, creates immense gravity that pulls all the stars in our galaxy into circular orbits. In addition, each star in the galaxy has a small random motion relative to the overall galactic rotation. The same concepts apply to stars in other galaxies. Each star orbits its galaxy's center and has a slight random motion on top of this. Each star does not careen randomly about like a drunkard. Rather, each star travels on a smooth, nearly straight trajectory as dictated by its own momentum and the local gravitational field. But when comparing the motion of many stars in a galaxy and subtracting out their galactic rotation, you end up with a random distribution. The reason for this is simply the randomness of the materials from which the stars formed, and the tendency of objects to drift under their own inertia in nearly the same path for eons in the near vacuum of space. The textbook, Exploring the Cosmos, by Louis Berman states, "There is, as we shall see, an individualized random motion, albeit slight, superimposed on a large common systematic movement shared by all the stars as they revolve around the center of the galaxy." The principal movement of the stars within the disk portion of the galaxy is the Keplerian motion. The closer the star is to the gravitational center, the nucleus of the galaxy, the faster it moves. This behavior is similar to the planetary motions around the Sun, since the law of gravitation is the common operator in the solar system as well as the galactic system. Within the nuclear bulge where the stellar density is greatest, the action approximates that of a solid structure. The farther the star is from the center, the faster it moves. The individual stars well above or below the galactic plane, constituting the halo population, and the spherically distributed globular clusters move around the galactic center at all angles of inclination in highly eccentric ellipses. Their motions are analogous to the motions of the far-ranging comets orbiting the Sun. For more video like this, visit and subscribe our channel.